docs.microsoft.com. All this documentation is open source, so you can make a change if you think something's not correct, or add comments if you want to know more about something. And you can look through this and get a lot of detailed information about each product. This is really the authoritative source for information about each of our services. Now, we've also published a lot of samples as well. These are all on GitHub, and these are really code samples for different scenarios across a range of different languages, a range of different services and use cases. So, for example, if you are going to be working with Azure Cognitive Services, you might want to have a look at some of the samples here to see how that can actually be used in your particular language, and see maybe even a complete working application that you can then use as a base to start your own. And then finally, the Azure Quick Start templates. So if you're familiar with Azure Resource Manager, that's the way that we deploy resources in Azure. And Azure Resource Manager has these things called Azure Resource Manager templates, or ARM templates. ARM templates basically let you describe the infrastructure or the resources that you want to deploy in Azure. And that you can put that into a way that means you can then redeploy it later, or you can provide it to somebody else as a template. So in this Quick Start templates list, we've got almost 1,000 Quick Start templates. Again, these are open source, and you can use this as a way to look at common scenarios or common ways that people deploy resources in Azure, and then look through how that's actually done. So you can try and understand how somebody actually constructed a template to do a particular job or to solve a particular problem. Or you can even just lift this template directly if it happens to solve your problem, and you can just execute this as it is. So this is another great resource when you start to actually implement applications and solutions inside Azure. So now I'd like to hand back to Dan, who's going to talk to us about how we think about architecture in the cloud.
Thank you very much, John. Now we're going to talk about cloud architecture. And what does this mean in the cloud? So solution architecture is concerned with the planning, design, implementation, and ongoing improvement of a technology system. The architecture of a system must balance all sorts of requirements and capabilities. As you know, the role of the architect really is to help businesses to understand the trade-offs and the balance, the compromises between different requirements and technical capability. It's a really important role. And the role of the architect in the cloud is really someone who assists a team to design solutions that are fit for purpose. And in the cloud, this role is known as a cloud solution architect. In many teams, the architect is a role, it's not a specific job. It's important that every engineer learns cloud architecture patterns and practices, and that we put that hat on from time to time. There's a really interesting question around modern software development and Agile, and do we even need architects? Is that role actually necessary? Well, I would argue that the role is definitely necessary, not necessarily the job itself. So some teams have moved away from having dedicated architects per se, but the role is still important. The need for good architecture remains. In fact, I would argue that it's crucial in an Agile environment, because those important business requirements around reliability, performance, operation excellence, cost and security haven't gone away as part of the new Agile world. And one approach that some Agile teams take is that all engineers will share the role of the architect, that they'll put that architect hat on from time to time. Another approach is that an architect will be made available to the team as an advisor or a consultant. And Microsoft Fast Track for Azure engineers are available to teams in that capacity. If you'd like to learn more about Fast Track for Azure and how we conduct architecture reviews, then please follow one of the links to the Fast Track for Azure page, where you can get enrolled for that program if you're not already. Now, way back in 2002, there was a really interesting piece of research conducted. This was actually commissioned by Microsoft and Gartner, and was conducted by NIST, and this is all about the relative cost of fix. Basically, what this study concluded is, what's shown in this example is that if we shift left that problem of detection, then we can make large savings in the relative cost of fix. And I'll give you an example. We all know that it's expensive to fix defects in production. A Sev1 prod issue is expensive. We have to bring in lots of different resources. Changes are difficult and take time. It can be quite stressful and quite taxing on teams. So what we've learned to do is to shift those problems left as much as possible. First of all, with testing. So if we have good testing in those testing phases, that helps a lot. Test-driven development has revolutionized the way that we develop code and reduce those P1s in prod.